For this first one, it says a Coast Guard rescue boat needs to reach a stranded vessel 15 miles due east. The ocean current's flowing south at 3 miles per hour. If the boat can travel 20 miles per hour in still water, what bearing should the boat head to reach the stranded vessel directly? Little bit of extra information. The fact that it's 15 miles due east doesn't really come into play right now. If they had asked how long it would take them to get there, probably would be a little more important, right? But right now we just have two things affecting the boat's direction, all right? So if the boat is trying to go 20 miles across due east, what is the boat doing? Well, the boat, there's no angle involved here. So straight across, the boat is attempting to do something like this, right? That's what the boat thinks it's doing, yes? What's happening to this is the current is affecting it, right? And so the current is doing this to it. And so overall, you actually don't even have to calculate speed or anything right now. They're really just asking about bearing. They're really just saying what directionally is happening to this boat, right? How do you correct it then? Because right now, this is what's happening to the boat, right? Does everybody see that? Yes, no, maybe. And so what angle is it pushing it at? Well, how do we find the angle of something? We do the inverse tangent. So if you do the inverse tangent here, what do you get? You get approximately 8.53. If I were giving this to you, I would probably give you at least two significant digits. So I would probably give this to you like that. Right? Because if I'm navigating, I probably don't want to round to the nearest hole. If you rounded to the nearest hole, it would be 9 degrees. If you did two significant digits, it's 8.5 degrees. However, how is it pushing you? North or south of that east? It's pushing you south, isn't it? South of east. So what do you do to correct it? Remember we talked about this? North of east. So you would say with one significant digit, if you did that, 9 degrees north of east. If I had given you two significant, you would get something like that. All right, so this is a little bit different. I did throw in a little extra nugget here for you to have to do, right? So most of these were like, I'm going north, I'm going south, or it gave you your X and Y components. So like on your quiz, it actually said, here's your east movement, here's your north movement, here's your west movement, here's your south movement, right? For your initial and your final, and you just had to worry about subtracting them. For this one, you actually had to do some calculating before you did your subtraction. Initially, this drone is heading 20 kilometers east. So we do know the initial piece of this, and that is just 20 kilometers east and 0 kilometers north or south. So we do know that initial without any calculations. But the final is a little bit different. They say 45 kilometers per hour northeast. So anytime they give you a perfect northeast, southwest, whatever, those are 45-degree angles. Both positive. North and east are both positive. And so you do have to calculate just like we would have done in the other chapter as well. The magnitude of that, how fast it's going, times the cosine of that angular movement is going to give me my x displacement. That magnitude times the sine of my angular movement is going to give me my y displacement here. So this was a little bit different. It threw in a little extra. And so we're going to calculate our overall magnitude of our displacement, and then we're going to convert it and divide to find our acceleration. Okay, so I do need to calculate this. It's going to be the same thing because the cosine and sine of a 45-degree angle is actually the same thing. So that's what's nice when it's both positive there. But that's my final. So I am going to subtract. I'm going to subtract my x's and subtract my y's and then calculate that. So subtracting the 31.8 minus the 20. And of course, this is subtracting 0. How do I find overall magnitude then of that displacement? yeah, I'm going to do my Pythagorean theorem. You know, it's just the square root of this squared. So I'm going to take that and I'm going to say 11.8 squared plus 31.8 squared in that root. And in your calculators, if you use your square button, you do not need those parentheses. Just leave them both positive. Do your parentheses like that, right? So that you have it correct in there. And so when you get that, you get, and I'm going to worry about significant digits at the end. Again, I would likely put a decimal point at the end of that 20, and I would likely tell you 5.0 seconds here. But in the interim, you're going to get approximately 33.9 kilometers per hour. This is asking for acceleration. Remember, acceleration is always meters per second squared. All right, when you're doing the metric system. So meters per second squared is what I'm looking for. So I do need to convert here. All right. So on some of your quizzes, the conversions were incorrect. Remember, if I'm going from kilometers, if kilometers is on top, it needs to be on bottom, which means my meters will be on top. If my hours is on top, or is on bottom, the hour needs to be on top, which means my seconds will be on bottom. It'll always follow. So what I mean by that is, if I'm going from kilometers per hour to meters per second, it's always going to be this conversion. If I'm going the other direction, it's just going to be flipped, right? So you'll always take this and divide by 3.6. If I'm going from meters per second to kilometers per hour, I would multiply by 3.6. It's going to always be that conversion. That's still, you have only calculated your velocity, right? So my velocity right now in meters per second, I think when I rounded it to something like this, meters per second. That's velocity. To get acceleration, I need to divide by my time. That's how I get that second squared. So I need to divide by that 5 seconds. And you get 1.9 meters per second squared. I only gave you one significant digit in the question here. So you would, if you did it in significant digits, it would be 2 meters per second squared. Right? If I had given you multiple decimal places, which I typically would give you more than just one significant digit, it would be that 1.9. Remember, we have an initial velocity on these is only my horizontal. We're about to add in vertical velocity in our next section, which is why I wanted to make sure y'all knew this. We have a change in my y, which is my altitude, and we have my change in my x, which is my horizontal displacement. Those are the things you're going to see in these problems. So it says humanitarian aid drone is dropping supplies from a height of 100 meters. That height is going to be my change in y. It's above the refugee camp. If the drone is moving horizontally at 54 kilometers per hour, they just gave me my initial velocity horizontally, 54 kilometers per hour. How far horizontally will the package travel before reaching the ground? Okay. A couple things is they gave me meters and they gave me kilometers per hour. So once again, I'm going to do the conversion on that kilometers per hour. It's the same conversion we just did. It's going to be 1,000 meters per 3,600 seconds to do that conversion. So you should get that it's moving at 15 meters per second. We're going to set that to the side for right now because we need to know how long it falls. Remember, right now, it's only being affected by gravity, the falling piece of it. So I can calculate this by using that change in y formula. Change in y would typically include an initial velocity, but that is 0. So my initial velocity is not important here because it is 0 for my y. I am only being affected by gravity and time. Gravity, yes, 1/2. So we're going to say 100. We do need to multiply by 2, which I probably just did not do any of that there. 9.81 times squared. So we're going to do 200 in our calculators. That will help. Now your change in time is a little different. It's a little bit more. 4.52 seconds is what I get for that. And then we're going to multiply that by our 15 meters per second squared. rounded to two significant digits, 68 meters.